All right, so you guys, there are 3 formulas that are super important to this section in chapter 6. If you don't have them memorized, I would put it on my to-do list to have these memorized because they're really critical to a lot of the things that we do, but especially for this section. We have the distance formula, and that is x2 minus x1 squared and y2 minus y1 squared. We have the midpoint formula, which are the x's added and the y's added, divided by 2. And we have the slope formula. What? Welcome back to Algebra 1. Y2 minus y1 over x2 minus x1. Okay. Super important that you guys keep these formulas close to your heart. My suggestion is you memorize them. If you don't have them memorized for the final, you will not have it for the final. So the best thing to do when you guys are studying, it's called an information dump. So I think of it as an information vomit, but that's the way my brain works. You guys will study for your final. You super, like 5 minutes before you come into class, review the formulas, everything. As soon as you sit down to take your final, write everything that you can remember down. Just write it all down. If it's still in your brain, it's still fresh, you write it down. It's an information dump. Then, as you're doing problems, you're like, oh, I need the distance formula. Good thing I wrote it down before I forgot it, right? So, as soon as you come into class, even if it's not pertinent, take a piece of scratch paper and write all the information you just studied down, and that will help you remember it for the test, because it's a 2-hour test, so I want to make sure you guys are good to go on it. Okay. We are given that OEF is a right triangle. So let's go ahead and put the right triangle marker on OEF. And that M is the midpoint, guys, of E and F. We want to prove that distance EM is equal to distance FM, which is equal to distance OM. So we're going to try to prove that this distance is equal to this distance is equal to this distance. So the key word here is distance. So we're going to go ahead and take that distance formula, and we're going to apply it to EM, FM, and OM. So we need to find the 3 distances. So the first thing we need to do before we fuss with distance, because our distance formula is x2 and x1, so we've got to find the coordinates we're dealing with. So that's easy for E. 0 is x1 and 2b is y1. Not so easy for M because nobody gave us the coordinates. I give up. Nobody gave it to me. Too bad. I'm forgetting about it. What do you guys think it's going to be?
1A, 1B.
Uh-huh. So if this guy is 0, 2b, and F is 2a, 0, M is halfway between those things. So if I added 2a and 0, I get 2a. Then divided by 2, I just get a. If I take 2b and add it to 0 using this midpoint formula, and then I divide that by 2, I get b. Now you guys, you're in geometry. There is a understanding that you guys are mature enough to deal with these kind of abstract concepts. We got A, B. We didn't get numbers that we could count on our fingers and toes. So that requires a little bit of maturity. Once you accept that A and B is okay to have rolling around in there, then the next stage of understanding this chapter is going to be so much easier for you guys. We're not going to get numbers, but being okay with not having numbers and just having letters is a maturity thing, and you just have to be okay with that. If you're mature enough in your heart to go, Oh yeah, I can use the distance formula using the algebra skills that they hounded me with in junior high and hounded me with in high school. We're going to be okay having A and B instead of like 5 and 7. So it's a little bit of maturity, but if you guys feel like you have an understanding, give yourself a pat on the back for being a mature math student. Good job, guys. But we're going to deal in letters, and we're going to be okay with that because we don't have a choice. So we're going to have the midpoint, the distance formula between E and M. So it's going to be, we're going to throw up our square root. We're going to do x2 minus x1. That's A minus 0. Then we're going to square it. Then we're going to go y2 minus y1. That's B minus 2b. And we're going to square it. So once again, relax. Take a deep breath if this is giving you anxiety that we don't have letters, or we have letters and not numbers. We can simplify this because we've done simplifying shenanigans in algebra. A minus 0 is A. The squared is still stuck to it. B minus 2b is negative B squared. We're gonna square this negative B. A squared plus B squared and the square root. I would like you guys real quick to put a note. If this is true for you, put this note on your paper. Do not simplify this further. I have some people who want to make that A plus B. When you have items separated by a plus or a minus inside the square root, you can't square root the individual items. They have to be multiply or divide in order to be able to apply the square root. So unless this A and B were in parentheses and the square was on the outside of those parentheses, we cannot simplify this down. So we're just going to have to be okay keeping it like this. Okay, so this is it. This is what EM equals. So I'm going to go ahead and highlight it so we can find it again. We're going to compare that to FM. So for FM, I have to change my, let's change the X1 and Y1. It's going to be 2A and 0. So go ahead and put that in here. So FM is Y2 minus Y1 and X2 minus X1. So we simplify this down as much as we can. A minus 2A is negative A, and we're going to square that. B minus 0 is B, and that's squared. And the negative A, when we square it, gives us A squared. That is what FM equals, and fortunately for us, it's also what EM equals. Okay, so let's find OM. For OM, we need to change the X1 and Y1. There's no coordinates on O, so I give up. What do we do? Yes, it's at the origin. It's 0, 0. So that's also something besides the distance formula. If you were ready to give up because you didn't know the origin was 0, 0, put that on your list of things to study. This guy is at 0, 0. So X1, Y1 is going to be 0, 0. And OM is going to be A minus 0 and B minus 0, each one squared. That gives us A squared and of b squared added together. So, okay. OM, so let's do our definitive statement. Wrap it all up. So we're going to say EM equals FM equals OM equals square root of a squared plus b squared. Okay, final example of using coordinate proofs. We are given that MN, this guy in the middle here, is a mid-segment for the trapezoid. So if it's the mid-segment, let's go ahead and find those coordinates for M and the coordinates for N. The coordinate for M is going to be half the distance, or half of the coordinates from 0 to R. R is 2B and 2C, half of that is B, comma C. And unfortunately, N doesn't have a little guy at the origin, so we have to kind of noodle this one. We're going to have to do work for this, between A and P. So the midpoint between A and P is going to be 2D, I'm writing terrible, sorry. 2D plus 2A a plus sign. Divided by 2, and then 2C plus 0 divided by 2. So the coordinates for N, once again, if I want to divide these two items by 2, I have to do it individually. I can't, anything that's got a fraction onto it, each term in there gets that fraction. So the coordinates for N are D plus A, comma, C. And we know the coordinates for the origin, right? Okay. We want to prove that MN is parallel to OP, which is parallel to RA. When we don't have any information on angles, how do we prove two lines are parallel? Using coordinates. I'm going to give you a hint. We haven't used this formula yet, and we wrote it down on our paper. So, parallel lines have what kinds of slopes? Same. So we're going to be looking for same slope. Thankfully, so I need to prove that MN, let me see if I can get, the slope of MN is going to be equal to the slope of OP is going to be equal, and then the slope of MN has to be equal to the slope of RA. So I need to find the slopes to all of these. Thankfully, there is one little piece of information about those lines that's going to make this super easy for us. Can we find the slope without using the slope formula? What is it? And why? So let's just look at OP. What kind of line is OP? It's definitely straight, but how is it positioned? It is a horizontal line. What do we know the slopes of all horizontal lines are equal? Welcome back to Algebra 1. Slopes of horizontal line are all equal to 0. We know that. That's something that we've studied. So I can say OP has a slope that's equal to 0, and we say horizontal lines, we don't just put that it's equal to 0. We have to state that it's a horizontal line. That's our justification. If you throw things down on your paper and don't justify it, then it's going to be really difficult for you to get credit for that on your test. And this test is on Friday, so we want you guys to get credit. Okay. So, and then just so that you can see how the slope formula would work here, if I were to subtract the y's, we get 0 minus 0 divided by 2a minus 0. And then that's going to equal 0. The same stands true here. My y's are both c. C minus c is 0. So it doesn't matter what the denominator is because we've already gotten 0. On top, same thing here. 2c minus 2c is 0. That makes our numerator 0 and the whole slope is 0. So we're going to say the same thing for all of these. Slope of n is 0 because it's a horizontal line. And let's write that also for RA. The slopes of all the horizontal lines in the world are 0. Okay, so we proved, so let's go ahead and lock it in. So we say, therefore, because that's fancy terms for locking it in, MN is parallel to RA and parallel to OP. All right, so now we need the next part. We need the MN is equal to 1/2 OP plus RA. Those are distances. So, yep, you got it. We have to distance formula each of our 3 lines. So we're going to distance formula RA. We're going to distance formula MN. And we're going to distance formula OP. So RA, the beautiful part about horizontal lines, what am I going to get when I subtract my y? 0. So if I were to do the math, my, when I subtract my x's, it's going to be 2d minus 2b. And my y's are going to be 2c minus 2c. And that's going to squared. And that's going to 0 out. So I'm just left with the square root of 2d minus 2b squared. So look, I got 2d minus 2b in parentheses. I got the square on the outside. So in this scenario, the square root is going to get rid of the square. And the distance of RA is the difference between my x's. It's going to be 2d minus 2b. I'll highlight that because we're going to use it later. MN is going to be the, if I use the distance formula, and I won't for the very last one because that's too easy. So we take our x's and subtract them. So I got d plus a minus c squared plus c minus c squared. C minus c is 0, and I just get d plus a minus c squared. And the square root of that leaves us with just d plus a minus c. I'm going to highlight that because we're going to use it. And lastly but not leastly is OP. The length of OP is the difference between the x values. 2a minus 0 is 2a. So OP is 2a. So now I need to find out what 1/2 RA plus OP is. Because that's what we're trying to prove here. And I'm hoping it's equal to MN. So 1/2 times RA, which is 2D plus 2b, sorry, minus 2b, plus OP, which is 2a. Then I go ahead and distribute the 1/2 to each of these items. So half of 2D is just 1D, minus half of 2B, which is 1B, plus half of an A. Sorry, half of 2A is an A. So we want to take a peek. Do these match up? This is MN, and this is 1/2 RA plus OP. Do they match? Do I have a D, a plus A, and a minus, C? Sorry, we're going to change this just a smidge. This is, when we do the distance formula, it's D plus A minus B. Boom. Minus B. So now they match up, and we can say that they're equal.